One. Well, today I am going to be talking about one of my least favorite subjects in mathematics overall, and but I think it's a very important subject that should be covered, which is the issue of polynomial division. If you're a student, you, for example, might encounter a problem where your professor or your teacher might ask you, for example, imagine you stumble upon a polynomial such as 2x cubed minus 3x squared plus 4x plus 5. And I remember when I first encountered a problem like this in high school, and they asked us, okay, when you have a problem like this, I want you to divide this polynomial. And of course, you may be wondering, well, how do I even approach a problem like this? And the idea is that what you're gonna do is you're essentially gonna write this like you would, when you typically want to divide, like when we learned in pre-K how to divide numbers. The idea is that you apply the same process. So I'm gonna just write it like this, and it might seem like I'm doing this out of nowhere, like I'm pulling it out of my butt, but you'll see what I'm trying to do, and please just bear with me, right? I'm gonna write it, and the idea is that this, okay, we're gonna try to divide this like any number, and I want you to pay attention to this number here. This is technically a polynomial, and this whole thing is a polynomial as well. Okay, and the highest term that this thing has is an order 1, and the highest term that this thing has is of order 3. And so, okay, well, that's not very useful. So what do we do from here? So let me just copy this. What I'm going to do is that now I am going to multiply this term, x plus 2, times, I want to get at least my highest term to match. So I want to match this term right here, and not just the x cubed, but I want to match the 2x cubed. So what I'm going to do is I'm going to multiply first by 2. Actually, let's do the power first. I'm going to multiply this by x to the second, and then I'm going to multiply this by 2. And now you'll see that now I'm going to get 2x to the cube plus 2 times 2 is 4, x to the second. And now watch what, and of course I'm multiplying by this term, so this term is going to go right here. And of course, because it's an x squared, so you got to sort of like align them vertically. It's not going to go here because it's an x cubed. It's going to go here because it's an x squared. But of course, it's 2 to the x squared. And now this is our term right here, so this would be 2x cubed plus 4x to the second. And of course, we're subtracting them. So now this term cancels out, and this becomes 0. And now this becomes, well, negative 3 minus this becomes negative 7x to the second. And now this term right here goes down, or you pull it down and becomes 4 plus x. And now we're going to repeat the same process, right? We want to cancel this term, so we have an x squared. Oh, and I guess you could draw a line here too if you want. This is the way I would do it, right? Now I'm going to draw another line, right? So now we have an x2. So if we want at least a term, remember this is the dominant term of this polynomial of order 2. So I want to cancel this, and this is a negative 7. So I want to subtract this. You want to subtract the negative. So now we're going to multiply it by negative 7, right? Because we want to cancel it out. And now we want to multiply it by x. And now we're going to get negative 7x squared. You essentially just want to match this term, actually. It's to make it simple, you just want to get you want to equate this exact same term. Because you're going to be subtracting them either way, so it doesn't really matter. At least not in this case, but we'll be viewing polynomials where it does matter. And I want you to notice that in this case, right, you're going to get this. And of course, we're going to get negative 7x squared. And then negative 7x will become negative 14x. And now we're going to subtract it, right? But we're going to write exactly this right here. 7x squared minus 14x. Minus minus becomes positive, so that becomes 0. And then this becomes minus plus, so this becomes 18x. And again, we multiply by this, so then we would get negative 7x right here. Remember, we got to align it with this linear term. And now we're going to bring this down right here, which becomes plus 5x. x. Okay, now let's see. We're going to repeat this term one more time because now we want to get 18, right? So now we have x plus 2, and now we're going to multiply it by what? Well, 18, because if we multiply, we want to match this term, right? We're going to get 18x right here, right? 18x plus 36. Okay, so this becomes 18x plus 36 minus this becomes 0, and then 5 minus 36 is negative, that would be negative 31. Hopefully I didn't make a mistake. And of course we're multiplying by 18, so we're gonna put 18 here. And now I want you to notice, right, that now, right, let me see actually if I'm not making a mistake. I'm not. Great. The highest order that this number, which is this is a scalar or a number, there is no polynomial here. There's no variable. In fact, the highest order polynomial is technically x to the 0, but our highest order is an x to the 1, so we can't divide it any further. So therefore, the highest term that we can get would be x to the 3 minus x squared plus 4x plus, oh, sorry, excuse me. Let me just be more clear about this actually. So I'm just going to copy this. And now, right, we're going to write this up top because this is what we have. This is our, oh God, I feel embarrassed because I don't it's been so long since I've done these. This will be our this our here, it would be our quotient actually, and this is our remainder, and this is our divisor. So now we're going to write our quotient here. So our quotient will be 2x to the second minus 7x plus 18 minus 31 divided by x plus 2. And this is our equivalent statement right here. Or this is what this polynomial division is equal to. I remember when I first learned this in high school, I thought it was kind of impossible to do this because I was still a stupid kid who didn't really care much about math, but here I am teaching it to someone else. What an ironic twist. But this is what our polynomial division is. And this is what we get. We divided the polynomial by multiplying by the highest order to match terms, and then we cancel it. Let's do one more example. All right, sorry about that. I had a phone call here, but the example that I wanted to do was, for example, being redundant. What if we wanted to divide 5x squared plus 3x minus 2 over x plus 1? Well, we're going to do the exact same procedure we did in the last problem. We're going to write it like this. Okay. All right. We want to match the highest order. And again, you don't have to do this. This is a good thing to do if you want to, for example, again, to identify highest order, but as you'll notice, the highest order here is an invisible 1. And of course, here is 2. And what you'll notice is that, okay, I want to match this, which is 5 to the x squared. So I'm going to multiply this by 5. Well, we want a 5 and a 5x plus 1. Because if we do, we're going to get a 5x squared in front. And then we're going to multiply, and then we're going to get a 5x plus a 5x term, which is an extra term, which we really don't want. We're stuck with. Well, you'll see what happens, right? And of course, we're going to put this term on top here. I'm going to align it here with this because these are linear terms. And we're going to get a 5x squared plus 5x. And of course, we're going to subtract both of these. This becomes 0, which is good. We want to get rid of this term. This becomes, well, 3 minus 5. That's just negative 2x minus 2. Oh, this is actually great. Because now, I'm going to put a line here so we could separate it, right? Because now, I want a negative 2. I want to just make a negative 2 term. So I'm just going to multiply negative 2 times x plus 1. And then I'm going to get negative 2 minus 2, which is exactly this term. And now look. This becomes 0. This becomes 0. This becomes, oh, excuse me. This becomes 0. This cancels out. This cancels out. And we're left with 0. And so we're going to put the 2 here. So therefore, So therefore, 5x plus 3x minus 2, x plus 1 simply becomes, well, it's going to become 5x minus 2 actually, and that's it. That's what the answer is, which is crazy. And of course, if you what you could do actually, which is a pretty cool trick, is that you could multiply both sides plus times x plus 1. So for example, in this case, let me move it over to this side. I could multiply x plus 1 on this side. So let me write it in big terms, right? I could say I can multiply this out times 5x plus 3x minus 2, x plus 1, 5x, and of course I'm going to multiply this side plus x plus 1. And now look, this cancels out, this cancels with this cancels with this term, which is great. And we're left with 5x plus 3x minus 2 is equal to 5x. I'm going to write, I didn't write the parentheses here, but you could write it if you want, times x plus 1, which is pretty neat actually, which sort of unironically or ironically, we've factored out 5x squared plus 3x minus 2, which is funny. Actually, it's just another way of factoring polynomials. Now let's do a little bit more of a involved example. We're going to divide 6x to the cube plus 11x squared minus 31x plus 15. And I'm going to divide it by, let's say, 3x, oh, whoops, 3x squared minus 2. Okay, well, let's do it. Exact same procedure, right? We're going to write it like this, and then we're going to write the box. Every time I write this, I'm so tempted to write a square root, but oh well. What can you do? What can you do? Okay. All right. Well, let's see. Same process, right? We have an x cube here. This is it doesn't matter what number here. You could have 100,000. You can have whatever. The highest term here is the x, which is a 1. So I want to get a 6 here. So I'm going to multiply it by 2. And I want to get an x cube here. So I'm going to multiply it by x to the second times 3x minus 2. So I'm going to multiply. So let's see, right? So if I do this, this becomes 6. This becomes 6x cubed, which is good. And this becomes minus 4x to the second. So we're going to put, again, 2x here to the 2x squared. Jesus, I don't know how to speak English. Great. Let me move this a little bit more to the left, actually, so we have room. Okay. We're going to multiply this out. We're going to get 6x cubed minus 4x squared. This cancels out. Great. We have a 0 here. This becomes minus plus. So this becomes plus 15x to the second. We're going to bring this down, and we're going to get negative 31x. Okay. So now we're going to do the same thing. Now we want 15x cubed, and we have a 3. So what I'm going to do is that I'm going to write this out again, right? I want a 15, so I'm going to multiply it by 5. And I want an x cube. I keep saying x cube, x squared. So I'm going to multiply it by 5x. Let's see how this works out. So remember your pandas, right? We go here, we go here. We're going to get 15x to the second minus 10 to the x. Okay, that looks pretty promising, actually. It matches at least the first term, which is what we care about. So we're going to write 5x here. Again, these are linear powers. So this would be 15x squared minus this. Again, we're subtracting them. And once again, this cancels. And now minus, we're adding. So this becomes negative 21x. Okay. And then we're going to bring this down. Plus 15. Okay. Same process, right? I'm going to draw another line here. Negative 3x. We want a negative 27, so we can multiply this by negative 7 to match the 20. Did I say 27? I meant to say 21. So we're going to multiply this by 7 to get 21. Okay. And now we're going to, I mean, that's pretty much it. That's just negative 7 because the highest order is 1. If we multiply it by an x, we're going to get an x squared, which is not, we're going to have another division problem, which is not very useful. And in this case, let's see, right, we're going to multiply, I don't know what I'm doing here. Negative 21x, this becomes plus 14. Okay, that looks good. Negative 21x plus 14. We're going to subtract this whole thing again. So this becomes 0 minus this becomes 1. And of course, we're multiplying it by negative 7. Okay, so now I'm gonna leave this here. So now we could see, actually, now let me move it. So now I'm gonna move this here, and I'm gonna move this to the left, and I'm gonna move this to the right to save a lot of writing because I'm very lazy. We want to be lazy when possible, but not taking shortcuts. Okay. So now we know that this thing is just gonna, and we have a remainder of 1. I forgot to mention that we have a remainder of 1. So we're gonna have 2x squared plus 5x minus 7 plus 1, because we can't divide this any further. We're gonna get 3x minus 2 over 1. And this is what the solution is.